Alright, so in this video we're going to look at one example of an application of a quadratic equation. Now please understand that it's virtually impossible to cover one of every type of application problem that you could potentially see. So you're going to have to just deploy your basic problem solving strategies. You're going to have to think about what you know in regards to quadratics and try to transfer it over into whatever the application problem is. Okay? So here is, again, just one example, okay? So we have the height of a ball, it's thrown in the air, and it's modeled by this equation. We have h equals, so the h is like what your y usually is, and notice it's in terms of t, okay? It's kind of in standard form, except notice we're starting with the linear term, then we have the quadratic term followed by the constant. We're told that our height is in meters and our time t is in seconds. Okay? So the first thing we're trying to find is we wish to find the maximum height reached by the ball. Well, let's take a look at this quadratic a little bit more closely. Notice how our squared term is negative, so that suggests that, and as we would imagine, the path of a ball is going to go up and then it's going to go down. So the height here, yes, it's going to increase and then it's going to decrease, and then here's your ground. Okay, so the maximum height is going to occur right there. So what you have to be able to do is make the connection that, oh, okay, I really just need the vertex, and in particular I need the y value of the vertex. Okay, it's not asking for the time when it reaches its maximum height. It wants the maximum height reached by the ball. Okay, so we need to find our vertex. Well, since this is kinda in that standard form of ax squared plus bx plus c, we know that we can find our axis of symmetry by using this equation. Okay, so and remember, that'll give us the x value of the vertex, and then once we have that, we can plug into the equation to find the y that goes with it. So the negative b here, that's our linear term, so that's negative 24, and then 2 times a, the a is negative 4.9. Okay, don't forget about that negative in front. So when we clean that up, we get 2.45. Okay, now remember, that really is our t value, our time when that happens. So we need to find h of 2.45. So that'll give us a maximum height of 30.4 meters. Okay, so again, you're just substituting into the equation this 2.45 for t. Now, if you were allowed to use a calculator, which you are allowed to, and suppose that you did not have to find it algebraically like this, so maybe instead of the word find, which implies you have to show some work, perhaps it said write down, which implies you do not have to show work. If that were the case, I would encourage you to graph this in your calculator and then use the maximum button under second calc. It's number 4 under second calc, and you can simply use that to find your maximum. Alright, it'll give you the coordinates. Alright, it'll give you the x and the y value of your maximum on that given graph. So take advantage of that. But again, because of the word find, what's implied here is that we want to show some work. Okay, the last part of this question is we want to find for what length of time is the ball higher than 20 meters. So if we were to graph our h equation, it would look something like what you see here. And recall that we found the vertex already. Okay, and also there is a y-intercept here at 1. Okay, go back to your equation. Alright, if you were to put 0 in for t, you would get 1 out for y, which makes sense. If you're throwing a ball up in the air, you're not throwing it from the ground. Your arm is a little bit above ground level. Okay, so 1 meter above is where it starts. Okay, so we're looking to find the length of time. Alright, so how much time is the ball higher than 20? So what you want to do is approximate where 20 is on your graph, and then we're going to draw a horizontal line here. Okay, so y equals 20. So where this intersects, that represents where the height is equal to 20. If we want to figure out the length of time where it's higher than 20, we need to figure out how much time it is above 20 on our graph. So we need to find the intersection points here as a starting point to find out where it's equal to 20. So you're going to let the calculator do the work for you there. Okay, so in y1 you should have your h equation. And please make sure you are following along and you're doing this. So in y1, of course, we're not going to put in a t, we're going to put in an x. Okay, so you're going to have your h equation in y1. In y2, I want you to put in 20. And then you're going to go to second calc, and you're going to select number 5. You're going to find the intersection point. You're going to have to do this twice, one for each intersection point. Okay. So when you use your calculator to find those two intersection points, and again, don't just write this down. You need to practice going through the motions. Make sure you know how to find that intersection point. We're interested in the time values. Okay, we already know the height value is going to be 20 at those 2 points. So we want to figure out the length of time that it's higher than 20. So by subtracting these two values that we found, that will tell us how long it is above 20. Okay, so 2.912, or if we were to do our 3 sig figs like IB always calls for our final answers. Okay, so you can go beyond 3 sig figs like you see here and here for the middle part of the problem, but at the very end you want 3 sig figs. So okay, so that's just a little taste of an application problem.